all we're going to do today is create one single cosine from adding two waves. There really is only one major restriction. It has to have the same frequency or period. Now, there's something to be said. It's very easy to be a robot on this, guys. Very easy to be a robot. There's something to be said, like notice that I have negative 8 cosine plus 3 sine. So I have to have the same argument. So they can't be different. Like one can't be theta, the other one can't be 2 theta, because then that means the frequency changes. You know what I mean, guys? Now, sometimes they're in phase and sometimes they're not in phase. So like cosine and sine, we know that they're out of phase by 90 degrees. But when you add them, it creates one singular note as long as the frequencies are the same. If you don't understand any of that, all that means is that I can create one cosine from these two. Now, as soon as I do something like this, if I go negative 8 cosine 3x plus 4 sine x, I can no longer use that property to make one cosine. So you have a wave and you have another wave, and together, sum together, they make one singular wave. And I'm gonna tell you guys how to create, or I'll show you guys how to get that one wave. Now, why do you want sometimes that one wave? Because sometimes it's easier to analyze a function if it's just one wave instead of having two. Does that make sense to you guys? All right, so here we go. How are we gonna do it? It's very simple. So this negative 8, notice that it's in front of the cosine. So this negative 8 acts like an x value. It's not really an x. That's why I put a quote on it. That 3 in front of the sine acts like a y value. So what I do is I create a grid. So here's my second quadrant. I'm exaggerating it. Why am I exaggerating the second quadrant? Because negative 8 comma 3 is in quadrant 2. So negative 8, 3, point. Negative 8, 3. Are we still okay, guys? The amplitude is the distance from the origin to that negative 8, 3. So this is what you call the amplitude. If you want to draw your triangle, you can. And the angle that you want is this angle right there. I'm going to call that angle D. So I'm going to rewrite it in terms of A cosine theta minus D. Notice that it does not have a midline. It's just, I'm just taking two combined sinusoids and we're just going to make one cosine with an amplitude and a phase displacement. Are we still okay? Now you're going to need your calculator. So let's take out our calculators. Now, I think for you guys for now, tomorrow, next time that we meet, we'll do it in radians. But I think for now, I think you guys are better with degrees. So let's clear everything. Second, memory 712. That's actually the answer right there. And I'm going to put the mode in degree. Don't worry, guys. We'll be done pretty quickly with this. All right, here we go. So how do I do it? The amplitude is nothing more than Pythagorean theorem. Hopefully you guys can see that. Square root negative 8 squared plus 3 squared. If you want to get rid of that negative, you can, because when you square something, it's no longer a negative. So that's going to be square root of 64 plus 9. 73 cannot be broken down, so leave it as square root of 73. I haven't done anything crazy, guys. Now I'm going to get my angle. What angle? This angle D here. So to get angle D, you're going to go arctan of 3 over negative 8. And this is going to give you an answer in quadrant 4. I'm going to add 180 to it. This is not the only way to do it. You can find the reference angle, put arctan of 3 over 8, figure out this reference angle down here, and then subtract 180 from that little angle in green. So there's so many different ways. So here we go. Arctan, so second arctan, and it was 3 over negative 8. 3 divided by negative 8. And like we said, it's going to give us an answer in quadrant 4. We don't want that negative 20. I'll just go plus 180. And there it is. That's the angle I want. 159.44395. 159. 159.44395. 44395. So what is your angle that's supposed to be the same as this one? This one right here. Y equals square root of 73 cosine theta minus 159.44395 degrees. Close it. And we're going to test to see if this is true. Don't just take my word for it. See if it really is true. So how do you test to see if it's really true? Go to your calculator. Go to y equals. Type the original in y1. I already forgot what the original was. I got to go back. Let's see. -8 cosine theta. So -8 cosine x, close parenthesis, plus, what was the 3 sine? 3 sine x, close. And then I'm going to put my new one. Square root of 73. And get out of there, and then put cosine x minus, if you can use the exact, even better, 159.44395. 159 point, I already forgot, 44395. 44395. Before you push graph, check it out. Don't worry, I'm gonna go slow. I have my both answers in here, right? The ones that I have, y1 and y2. Before you push graph, push window. And because we're in degrees, you're going to go -360 to 360. X scale doesn't matter. Go by 90. And let's see, y min, 8, 9, 10, 11. So let's go from -14 to 14. So we can capture it all. And y scale doesn't matter. You can go by 1 or by 5. Push graph. Oh, it goes too fast. All right, it goes too fast, guys. Let me turn off the red one. I'll show you. I know that you guys don't have color ones, so I'll show you how to do it in a little bit. So here it is. I turned it off. I push graph. There's my blue one. So that's my y1, right? Look what happens when I turn on y2, the red one. It overlaps it. That means, boop. That means it's the same wave. Now I know if you don't have a color one, you can't tell. So let me show you a hack. I think there's a way that I can get that one. Emulator model, TI-84 plus. Is that the TI-84 plus? I'm not, okay. Oh, that sucks. Did it clear it? No big deal. All right, let me type it again. Let me show you guys how to do it so you can see. What was the equation again? -8 cosine x plus 3 sine x. And then on y2, you're going to type square root of, what was it, 73? And then cosine x minus 155 point what? Oh, 159. I would have been off. 159.44395. All right. Window -360 to 360. And I'll first do it like this first so you can see 90, then a -15 to 15, and by 5. And if I push graph, maybe you're like, yeah, it's the same. But what if like y2 graphs it outside the window and you don't know? So here's a hack. Click on y equals since you don't have a color screen. Go to y2 and then scroll all the way to the left. Make this one thicker. Just push enter. One time. Notice that now it looks like that. Do you see that? So now when I push graph, check it out. Let's see. Ready, guys? Boom. Look at that. Wow. It went really fast. But notice on yours, like, do you see how it is the same graph? So that's a hack on how you do it on a calculator that does not have color screen. But if you have a color screen, I highly recommend, now this is just me, guys, you're going to be in the university and at grad school, and you're going to need a calculator for the next 8, 9, 10 years. I highly recommend you buy yourself a TI-84 CE, maybe for Christmas, or, you know, tell your parents, like, for Christmas, please get me a calculator. That's what I would do. I got a calculator for Christmas in my junior year, and I loved it. I asked for another my senior year. Now I have like 15 or 20 calculators all together somewhere. Anyways, let's not talk about me. Let's talk about math, right? So yeah, there it is. Let's keep going. Let me change to my color screen here. View. I like the color one better. Do I still have my stuff? Yay. All right. And that's it, guys. Pretty cool, right? What's up? Yeah. Window, bam.
What? There's no X.
There's an X. Is that the TI-89? Yeah, the X is right below the home button. It says home and it says X, Y, and Z. Do you see it? Right on, like where the number 7 is, go up 2 to the left 1.
Oh, they're actual buttons. They're not like right on the top.
Yeah, they're buttons. All right, here are some formulas, guys. I'm not a big fan of formulas because if you notice, they don't really explain much. They just say, here's how you get your answer. But hopefully you guys understood this explanation. This is just a grid to help illustrate like where quadrant you're going to be in, like what your angle you should use. Does that make sense to you guys? All right, so now we're just practicing. So question number 2, we're doing the same thing. It says 4 cosine plus 3 sine. So that 4 in front of the cos acts like an X. That 3 in front of the sine acts like a Y. Remember, we can also do it the opposite. We could say 3 sine plus 4 cos. Whatever's in front of the cos is an X. Whatever's in front of the sine is a Y. So just because we do it in this order doesn't mean. All right, so here we go. I'm going to emphasize quadrant 1. I'm going to go 4 to the right, 3 up. I'm going to put a coordinate there. That is a 4, 3. This is my amplitude. And here's my reference triangle. So you can tell, you don't need to do Pythagorean theorem if you already see it. This is a 3, 4, 5 triangle. But if you don't see it, guys, it's no big deal. 4 squared plus 3 squared equals the square root of 25, which is 5. We're still okay? The angle I want is this one. So D equals arctan of, let's see, y over x, so 3 over 4. And I'm not going to add 180 because the calculator is going to give me an answer in quadrant 1, which is what I want. So let's see, I go here, second quit, arctan, was it 3 over 4 or 4 over 3? 3 over 4, 36.86989. 36.86989. Put the degree symbol. If you don't put the degree symbol, it's a radian, guys. So make sure you put the degree symbol. So your equation is y equals 5 cosine theta minus 36.86989, degree symbol close. This is equivalent to that one. And if you want to test it out, you put it in y1 and y2 and see that it's the same graph. It is. Are we okay so far, guys? All right, did I put the degree symbol on the last one? Yeah, good habits. Last one, and then we'll let you guys loose. As you can see, it's not that bad. So again, negative 15, that acts like an x coordinate. That 8 acts like a y coordinate. I'm going to emphasize quadrant 2. Negative 15, 8 point, not to scale. The amplitude is the distance from the origin to that point. Here's my reference triangle if you want it. The angle D is this angle. So the amplitude is square root. I feel like this is a Pythagorean triplet. I think it is. I think that's going to be 17. But check it for me just in case, because I make mistakes all the time. I got a thumbs up, so that means it's right. I took geometry. You guys did too, so you guys knew that. Do you guys remember triplets in geometry? 3, 4, 5, and okay. It's okay. It's okay. Don't. Let's not blame anyone, guys. It's okay. D equals. This is a topic in geometry, so that's all I'm saying. I'm not saying anything else. So D equals arctan, and I'm just going to write y divided by x. You don't need to do 8 divided by negative 15. Remember, there's other ways. You can just do arctan of 8 over 15. That's going to give you the reference angle. And as long as you know you're in quadrant 2, 180 minus that reference angle. So you don't need to do it this way. There's other ways. I know that this is going to give me an answer in quadrant 4, so I'm going to add 180 to it. So I'm going to go arctan. And I already forgot. What was it? 8 divided by negative 15? And I'm going to push enter. Plus 180. 151.9275 degrees. 151.9275. Let me make sure that I said 9275. Yep. If you can put the perfect, the more digits, the better. because if you were to actually look up the table, they're going to be off just a little bit because we're the precision we're rounding. So here's your equation, guys. Y equals 17 cosine theta minus 151.9275 degrees. So this equation here is the same as that. They're equivalent. Yes. Uh-huh. Oh well, it's this angle here, just like it's this angle here. It's the same, like, but the negative 20 gave us this angle here as that, so that's why we added 180 to get to this. So it's the angle inside this triangle right here, where it terminates. Did that answer your question? The angle that it terminates. Any other questions, guys? Ask, guys, because I can't read minds, especially with math. Like I can't. You guys look at me like this, and I don't know. Like you can't tell. All right, I think it's pretty straightforward. I don't think it's anything extreme. What's up? Ask.
Will it always be cosine in the last equation?
Yes.
And will it always be theta minus that number?
Yes.
Okay.
Now, okay. Yeah, that's a good question. I already graded. What was last year? Sixth period. I graded sixth period, and I guess you're gonna learn from their mistakes. Sorry, sixth period. If you're hearing this, don't give me a thumbs down. Some of them have answers in quadrant 4. Like let's say I am in quadrant 4. So I don't know. I'm just gonna make 3 cosine theta minus 4 sine theta. Y equals. And they went ahead and they were like, oh, I'm in quadrant 4. It gives me a negative angle at 360. You can do that. It's the same. But if you're already in quadrant 4, use that negative angle. So it would be theta minus that negative angle. So it would turn into a plus on the inside. So theta plus whatever. Does that make sense, guys? And remember, worst case scenario, you can verify it, put it in the calculator, like, oh, I'm not sure, y1, y2, and see if it's the same graph. You guys know what I'm talking about? Yeah, so it's not that bad, guys. All right, let me turn this off, and this is a video that I will upload in case you're wondering.